let me just show you why we introduced this absolute value definition and why they have this more formal definition here, right? So we learnt about an absolute value. We know that if I put any number in it, whatever happens, it will always become positive. But I said that this definition isn't really sufficient when we're trying to think about variables. It doesn't really make sense. Like, for example, if I gave you an equation that looked like this, have a think using maybe this number line, what could my answers be? If the absolute value of x has to equal to 2, what is that going to look like? Plus or minus 2. Because remember, the absolute value can be thought of as the distance from 0, right? So I go 2 units to the right or 2 units to the left, right? But the distance that's traveled is going to be 2. And you can check that on your calculator. The absolute value of 2, that's just 2. The absolute value of negative 2, that's also 2. So in this case, x equals to plus or minus 2. Okay? So something like that's not too bad. What about something like this? What would that look like on a number line? Good, right? Because what does it represent? It says the distance traveled is this, right? The distance traveled is this, okay? 7 and negative 7 there. That's the distance there. But to think about the x value that's going to give me that situation is a little bit tricky, right? I mean, I could really easily say, okay, I know that if x was 3, 3 plus 4 would give me 7. But if we're trying to think about like the other direction, how do I get to negative 7? That is a bit tricky to think about. And if we start introducing more variables, then it gets even harder to think about. So we want a better definition to do that. I know what it would look like visually. I know that the distance from 0 has to be 7. That's essentially what I'm looking for here, right? In terms of x plus 4, though, to solve that, coming back to this definition is a bit easier. Whenever we have absolute value, we always have two cases. Either I'm looking at the positive case, so I'm going in this direction, right? I want to say, okay, x plus 4 would equal to 7, and I can solve that like a normal equation, x would equal to 3. And you can check that on your calculator. I'm just chucking in the absolute value, 3 plus 4, it does, oh, sorry. Hang on. There we go, 3 plus 4 does give me 7. What's the other case I want to consider there? Minus 3, minus 4. Let's try. So, minus 3, minus 4. That does give me 7, but what's the problem? Is that the equation that I've actually got? The equation I've actually got is x plus 4, and so minus 3 isn't going to be a solution to that. So, unfortunately, we can't just change the expression to give me this answer. I have to work with the equation I've got. Does that kind of make sense? Right? I have to stick with that plus 4 that I've got. So I've got some number plus 4 will give me 7. Minus 11. So we can see that. We can see that at the same time. We can see that, but how do we actually solve that? Because if I check minus 11 plus 4, that does give me 7. But how do I actually do that? I can either say x plus 4 has to give me 7, or x plus 4 has to give me minus 7. Right? I can go in the positive direction, or in distance-wise, I can go in the negative direction. Right? So if I solve it that way, x plus 4 gives me minus 7. Okay? Then I can say, well, solving it normally, I subtract 4 from both sides, and then I get negative 11, like that. Right? So can you see that's how we can obtain two solutions, right? I took the positive case, but I can also go in the negative direction there. Right? Does that make a bit of sense? Or a bit confusing? How do we feel about that? Sorry? Than the last one, yeah. Okay, because I think this makes more sense because we're actually doing something with it, right? We're not just kind of talking abstractly. Yeah. Let's leave it there. I'll put up 2 more examples. So this formal definition works in two ways. You can either write it out like this, or you can say, all right, the other situation is I have a positive case, or the other situation is I have a negative case, right? And if this is less than 0, then you would write it out. What would be the other expression you would write? You would write out the negative of this whole thing, and you could say that's equal to 7, right? So remember when we were talking about like, what are the two situations? Either this whole thing is positive, right? So I just write it as it is, or it's less than 0. So then I have to take the negative of that, won't I? Okay? If I take the negative of that, I should end up with 7. But what I've done here, I've just kind of multiplied both sides by -1 again, and we just get x plus 4 is equal to -7 anyway. So this comes from this definition, if you're following it that way. But this way, I think makes more sense to me, because I think about the absolute value in terms of distance from 0. Right? I say, okay, either x plus 4, it gets me to, that's not right. I say x plus 4, that gets me to 7, or x plus 4, it gets me to -7. So that makes more sense to me.
So instead of doing that stuff there, you just put a -7 there.
Yeah, right. So these are two ways of obtaining the same answer. It just depends which definition you're more comfortable with, right? And maybe we'll need both at some point, okay? But for now, if you're happy with this, the absolute value is the distance from 0 definition, I would go with that one in terms of solving them, yeah. Like if you look at something like this, right? I always know there are two cases. What's the first case I have? Like, come back to this one. The absolute value of x is equal to 2. So I always have a positive case, right? So the simple one is, okay, 2y minus 5, 4 minus 1 equals to 5. And then you solve it like any other linear equation. Yeah, y equals to 3. And you can check that if you put it in, right? 2 times, what is it? 3 minus 1, and it does give me 5. So we can still check these absolute value equations like any other one. How about something like this now? What is the other situation that I'm looking at?
2y minus 1 minus 5.
Yeah, right. So I could go in the other direction, go in the negative direction. 2y minus 1, that equals to -5, right? And then we solve it again as normal. Divide both sides by 2 at that point, so you get y equals to -2. Let's check if that's a solution. So I'll put in -2 times -2 minus 1, and I do get 5 over here. So those are my two answers to this absolute value equation. So kind of like quadratics, we have two possible answers. With absolute values, though, the way we approach that is slightly different. We think about the two cases. The two cases are I'm going in the positive direction away from 0, or the other case I'm going in the negative direction away from 0 as well.